Good day, science learners! Today, we will have a video lesson for a new topic. I am Sir Rowell, your grade 10 science teacher. Before we proceed, do not forget to like, share, and hit the subscribe button and notification bell for updates about our latest video. Kindly focus on the content standard and the learning competency for this lesson. For you to be guided on what you should do and what is expected of you after this video lesson. I hope you are all fine together with your parents and loved ones at home. Stay focused and enjoy our lesson for today. Our content standard is to demonstrate an understanding of the different regions of electromagnetic spectrum. And our learning competency is to compare the relative wavelengths, frequencies, and energies of the different regions of electromagnetic spectrum. Before we proceed with our topic for today, let us have some recall of the previous lesson we have discussed. Kindly identify the scientists involved who have big contribution on the development of electromagnetic theory, and scramble the letters to reveal your answer. Number 1. He proposed that the alteration of electric current and magnetic fields generating and propelling each other in space can be thought as form in moving energy. The answer is Maxwell. And here is James Clerk Maxwell. Number 2. He performed a series of experiments designed to elucidate the exact nature of relationship of electric current flow and magnetism. The answer is Ampere. And here is André-Marie Ampere. Number 3. He discovered that magnetic needle deflected when a current in a nearby wire varies, a phenomenon establishing the relationship between electricity and magnetism. The answer is Ørsted. And here is Hans Christian Ørsted. Number 4. He discovered that the changing magnetic field can induce current which then pass through coil of wire. And the answer is Faraday. And here is Michael Faraday. Number 5. He designed an experiment setup that was electrical in nature and be able to generate and detect electromagnetic waves. And the answer here, Hertz. And he is Heinrich Hertz. You are now familiar with different scientists who made remarkable contributions on the development of electromagnetic theory. They've proven through their experiments that magnetic field can produce electric current. James Clerk Maxwell proposed that the alteration of electric and magnetic fields generating and propelling each other in space can be thought as a form of energy as a wave, which he called it as electromagnetic wave. Now, here are some special features and characteristics of electromagnetic wave. Electromagnetic wave is a combination of electric and magnetic field. A changing magnetic field produces electric field, and a changing electric field produces a magnetic field. An accelerating electron produces an electric field of a wave. The varying electric field produces magnetic field. Both electric and magnetic field oscillate perpendicular to each other to the direction of the propagating wave. All electromagnetic wave can travel through a medium, but unlike other types of waves, they can also travel in a vacuum. They travel in a vacuum at a speed of 3 times 10 to the 8 meter per second and denoted as c, the speed of light. At this point, let us now explore electromagnetic spectrum. Electromagnetic spectrum is a continuum electromagnetic waves arranged according to the frequency and wavelength. It is a gradual progression from waves of lowest frequency to the waves of highest frequency. Electromagnetic spectrum can be arranged according to increasing frequencies. This includes the radio wave, the microwave, the infrared, visible light, ultraviolet rays, X-rays, and gamma rays. The different types of electromagnetic waves are defined by the amount of energy carried by or possessed by the photons. Photons are bundles of wave energy. Among electromagnetic spectrum, gamma rays have the highest energies, while the radio waves have the lowest energies. On the other hand, in terms of wavelength, the wavelength of radio wave can be compared to the height of a building, while the wavelengths of gamma rays are as small as the nuclei of an atom. The waves in the various regions of electromagnetic spectrum share similar properties but differ in wavelength, frequency, energy, and method of production. To better understand the lesson, let's take this activity. Study the data presented in the table. The table shows the relative wavelength, frequency, and energy of each different types of electromagnetic waves. Then kindly answer the guide questions after. Please refer to the data shown in this table. You may also look at your module as guide for this table. Let us now answer the guide questions. Which electromagnetic wave have the longest wavelength? The answer is, you're right, it's radio wave. Number 2, which two waves lie at the ends of the UV ray? The answer is, you're right, it's visible light and X-rays. Number 3, which rays lie at the other end of electromagnetic spectrum? Very good, it's gamma rays. Number 4, arrange the electromagnetic spectrum according to the increasing frequency. Okay, that is radio wave, microwave, infrared, visible light, ultraviolet rays, X-rays, and gamma rays. And number 5, arrange the electromagnetic spectrum from the shortest wavelength to the longest wavelength. That is gamma rays, X-rays, ultraviolet rays or UV rays, visible light, infrared, microwave, and radio wave. Now you all know the regions of electromagnetic spectrum. These regions have practical applications which will be discussed on our next video lessons. That's all for today. Thank you for watching. Goodbye!